Okay, let me check this music. Testing music and sound. Testing. Right. Okay, first thing in the morning is what are these pictures? Chiacota, Lake Bolivia. Awesome. Alright, let's do okay. Maximum product of word map. Given a string words, return the maximum value of word I. So basically two. If no two such word exists, return zero. So that sounds like a sort problem. And is it a sort problem? If we can find, they just need to find the maximum, right? So basically, max of AB be basically find the first and second max, isn't it? So not necessarily need a loop, sort. Just do a to loop, right? So the second thing is, so the two word has to not share common letters. Okay. So basically we have to find no common share letters. So that means we have to find words that share, that has no intersection, right, with one another, right? Okay. So the first part is easy. The second part, let's see. You have so ABCW will share with what? So ABCW share with this, and this. So basically, we have to have some kind of index so that we know as we loop through these, we know where each character is. Okay? So basically, A B C W, A B C D E F G H I J K L M N O P Q R S T U V W X Y Z alphabet. Yeah, XYZ is that, right? So ABC, we will fill it up. 111, right? BA will be 2, 2, 2, 1, right? BAZ, F will be 1, 2, right? Bar, 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 this one here. Okay. XDFN 1, here. F. Wait, so we just need to find the 2 word, right? So putting them on the same frequency here would not work, right? So which is it obsolete this. So what's the topic? Array string bit manipulation. Okay. If we look at these and like a brute force solution, would just do AB right, but ABCW, then it would just the only thing we will have. Oh, wait, what is this? ABCW, then the option we have is foo, XDFN, that's it, right? Bars, right? Bars will have foo, XDFN, right? Then foo will have, foo probably have ABCW. Bars, bar, XDFN, and oh no, not XDFN, something like that. And then bar will have oh wait, that's the thing, right? Can we do XOR, right? Because basically XOR give us a way to say that if out of these, right, let me check. String, let me do that in Python here. So I do Python string to binary. We do that. Oh wait, we can just do which is this. Right. Okay, let's call this and B equal to E for E and S, right? Convert. Can we convert string to integer, right? Oh, we do this. Okay. Isn't that string ABCW? It just ASCII add together, right? String to binary, right? For example, you have ABCW, right? Will be this. Right? ABCW will be this. Right? And then BAZ. Right? BAZ will be this. BAZ, right? Right, so let's zero out these, right? So because character B in binary, right? 0 10 what 110. Oh, this is Z. B is this. Okay, let's do BIZ. Let's go to Gemini and ask it to convert them to binary, right? So right, to binary. Okay, which is right. Just copy this out. And we have these. We don't need this. right? An ON square would just do like for each character here XOR them together if they are the not zero, right? For example, do ABW XOR with BAZ, and another example of ABCW XOR with foo, right? So at least that's the way that we can find if they share a common letter or not. Otherwise, we probably have to construct a try, right? See, this one is sharing this, right? Because yeah, yeah. So this one share these, right? I think. Wait, hold on. Meaning since A, B, C, W, yeah, full share no context result is the union of in visual except be the same as the O. Summary, right? So A, B, C, common letter none, right? Wait, is that XOR the right approach though? Because these share the B in A. Right. So then it would just give you CW. Right. So, oh no, CWZ. Right. Which is not, doesn't seem like a good way to figure out if we found that they have sham common, right? Another approach we could do is like we compare the difference between a frequency table, right? So let's see if our ON square work, right? Yeah. So because for each character we find out there if they share common word, right, between any of these, right? So does it make more sense to can we figure that out with the sum of the frequency, right? So frequency for the first letter is A has first letter is A1, ABCW has A1, B1, C1, W1. Buzz has B1, A1, A1. So we have like a common. Let's do a big. So A we got 1. B first we start out with this, right? And then B will make it become this one. A will be 2. And we add Z to here. and we also have we should have a pointer to basically two because of ABCW and BIZ. B because two because ABCW and BAZ. C1, sorry, because ABCW BCW, right? Z1 is because of BIZ. Okay, so now foo, let's put them by the space here. Sorted by okay. So now we have foo is F1 foo, right? O is 2, also by foo. Then we have bar, so bar put them in here, bar, right? So this will be 3 or here, bar. Okay, XTFN. So let's make it 2 XTFN. So X first, let's do X. XTFN. XT F, make it 3 or 2 already, right? Yeah, I already put that. And will be 1 XTFN. Okay, and then we got A, B, C, D, A, F. A, B, C, D, E, F. B this. A, B, C, D, E, F. B, C, there's 2. B, C, D, E, F. C, D, right? D. B, C, D, E, F. E, 1. A, B, C, D, E, F. Right. So this will be 3. A, B, C, D, E, F. Right. So we need to find the 2 words that not share the common letter, right? So these words share, right? And we need to find the one that does not share with anybody, right? So we do right, so another way to look at this is we have A B C D E F N O R D X W Z. So 4 4 2 1 1 P 1 2 1 1 1 1 1. Right? Does that help us? Does that help us with anything? So the only option we should pick is no. I don't think like that could help us in any way. Right? Me think about it for a little bit. Right, so maybe writing in paper would be better. And writing on note. Okay, so somehow we gotta find all the words that do not share common letters. Right? So the thought earlier was if this share with anybody, right? So this from this we found the one that does not share, right? So we have basically a list of stuff. So can, for example, for A B C W, we know we can compare them, but let's just implement the stupid solution of ON square. Let's see if it is even passive, right? So basically what we do is for word in word, for I in range of length of word, right? So we basically have ON square stupid for J in range of I to the same, right? Length minus 1, right? So basically we found two words, right? We compare their frequency, right? And we basically Fi Fj equal to we have like a frequency, right? So frequency of the I equal to 0 for I in 26, right? Because there's only 26 characters, right? 0 if what's that? Okay, so hold on. We gotta look for C in words I, right? So this word we convert to numbers, right? Ordinal C minus the ordinal of A, right? Lowercase, right? So this give us, let's say A, right? A will be 0. And okay, so first we got a loop, right? for I in range of 26, right? Okay, let's just make it simple. C in word, right? So first we do, right, 0 multiply 26, right? Right, this gives us the frequency, and then do this for C. Okay, let's just make a function frequency, right? Given a word, you want to return a frequency, right? And then we for C in word, basically f of ordinal of C minus ordinal of A, right? Plus equal 1, right? Basically, and then we return f, right? So basically we have fi equal frequency of word at I, right? Fj equal word frequency of word j, right? So this gives us the frequency, and then we basically saying we technically can do a bit, right? Technically, this, instead of an array, we can store them in an integer, right? And do bits operation, but the idea is the same, but with the bit operation. You can do XOR to see common letter. I think that's the thing, but that's fine for now. So let's see if frequency diff is same is share, right? Common letter, common frequency, right? So basically, given f1 and f2, basically we gotta say that for I in range of 26, if f1i and f2i both greater than 0, right? Greater than 0 and f2i and 0 does not mean it is share, right? Return true, otherwise we return false, right? So basically, if is share common frequency, right? We pass in fi and fj, and we know that if not share, right, then we calculate the max product with length, right? It will be max, oh yeah, it's 0 already, word length basically equal to, let me copy this, and the result of multiply the length of words I and the word j, right? So yeah, so and then this is just a first stupid solution for the hard coded, right? For the see if it even passed. If it passed, then we can look to see if we can optimize them. But what? Okay, so this is wrong. Gotta do this. Okay, yeah. So at least that solution is okay. Submit to see if it passed. Or is the timeout? Right, looks like it's gonna time out, right? Oh, yes. So that is the last use case, right? So this solution is no go. So let me write step down and see. So somehow, if we can figure out a way to know, so ABCW we know some, BAZ we also know some, is sharing, but do we want to list out the one that is not shared here and then do that? Because time limit exceeded. I knew it. Because this is basically ON square, which is not good. Must do better. But how, I don't know yet. So ABCW is the word. You can lay out in ABCD. I don't feel like that's the good solution, but how do we quickly know that? Okay, these and these. So ABCW, right? We have an option for full bar, no full, and XDFN. How do we quickly know that? Right, and then bar is like what? So ABCW, we have full and XDFN. BAZ, we have full and oh, this seems out to me like a union fine, right? Right. So let's think about that way. Okay. So we have connected component ABCW is one component. It's shared with BAZ and BAR, right? And because the requirement is picking the longest, right? Picking the longest, so we choose ABCW to be the root, right? And another component is, okay, this one is A, B, C, D, E, F, right? Or whatever, we can just pick one, right? And then another component we know is A, B, C, W, B, A, Z, bar, okay? Okay. And then we have foo, doesn't share with anybody. And then XDFN, right? So then what is left is we just need to find, oh, the one that don't share. Oh, this one also share with this one exists in, so this is not, maybe not a good solution, right? I'm stumped here. Can you get some hint? They don't, then don't worry about. Anyone quit. Yep. Okay, so they're saying if I do bit masking, it will work. What? Okay, so they're saying don't try to come up with a ON solution because we don't know it exists. Okay, so we can try that. Really? Me try not to look at the solution, but yeah, that one test case give me headache. Getting time. I don't want to look at solution, but seems like people is they're saying bit manipulation will work. Okay, so let's try that. Let's change this function to frequency bit. Okay. Forward. Basically let's rewrite our function to do instead of this. We're basically saying so each word So A will map to, okay, let me write it down here. A map to 0, right? So we want to turn a number for C in word, right? So ordinal of C minus ordinal of A. This will give the bit position, right? The position is, if we do, let's say ABC, we want to store the number is 111. So the question is, do we want the reverse, right? Which is like, instead of this with ZW X, because we want to just shift by, okay, bit mask 0. We just return the mask, right? So basically this one shift that many mass or equal, right? Does that work? Like that. You're hooping me. Alphabet set to raise 20 billion from US dollar bond side. Whoa, you going that? Okay. So basically what we need now is right, everything else remain the same. So I owe this, right, which is for ABC. I will have basically CBA, right, 0 2 1 0, right? So depend, I ship them, right? Because I don't want to ship by the 26 minus whatever, right? I think. Okay, so now if we want to compare if they are the same, then we just compare corresponding position, right? So we need to do for I in range of 26, right? If F1, we need to do the corresponding bit and ship to the right 1, right? So basically mass equals 0. The mass first, so somehow we need to do F1. So we have, for example, if we want to do is ABC and W somewhere, right? WXYZ to 25, right? 5 2. With BAZ. BAZ will be 26, right? No, this is 24. This is 25th. 210. 25 B. Right, so it will be B C C. B here will be what? Uh, B A Z. Yep. So now these letter corresponding to number one, right? So we need to like compare the bit if they are both set, and then that mean they share. So we just need to. So this is F1, this is F2. We need to figure out the bit. Do we just end them together and do we just ship? We ship and end. Let's do that. So F1 ship by what? 26 minus I, right? So this letter right here, we ship what? How many times? 25 times, right? Which is 26 minus I minus 1, I think. If this and the same thing but F2, right, is set, then that means return true, otherwise return false, like that. And then we can use this test case, see if we will pass. Chat discussion said that bits Y will do good. Okay, what is this? Python binary bitwise or does it not let me do that? Or do I do this? Right. Built-in method function is not subscriptable. What? Oh, I think it doesn't complain about this. It's complain about this one right here because it's a function. Let's see. Does it even pass? Okay. Time exceeded. What? But first we gotta to see if it even passed the normal case code. No. Right, so really? I did that, right? People saying n square will be fine. Oh, okay. So maybe because I recompute them here, right? Right. So back to the wait, hold on. Let's figure out if the bait mask is working first. let me print out the word here. What's I Python integer to binary. Can I do that? Bin 10. Okay, bin 10. Bin up fi. I think the problem here is could be that I did not try cache it. So is it correct? W here, okay. A B C good. A B C W, alright, okay. So let's add the cache here. Before we add the cache, make sure that everything's working. B A Z, okay, good. B A R, okay. So first is we do +1, right? Okay, hold on. So assuming that this is correct, so we print words I, word J is common. There's no comment, right? That's crazy. So some of the method we wrote is wrong. Let's do that. Words I fi word J fj. That binary. Okay, so why is it not the same here? For 26, you shift left 26. So if the first character 26 minus 0 minus 1 is 25 times, would be we do f1 I equal f2 I equal so if f1I and f2I is basically 1, then return true. Let's print out this 1I 2I be a lot of print. Yeah, so this share command good. Cool. Why does this share command though? So we have 0, 0. Who is what? This one should not be common, and it is. What? So maybe we need to let's do, we shift the one up by this many. Right, we shift one up by that many. Right, and then we end with this, and then we shift back. Okay. Oh, this is problem with copy paste. Yeah. Hold on. Let's undo this. Right, this will be F2, my guy. Okay. So let's use this case here. I don't know if we're passing. I don't think so. Right. So one thing we can try is, we shouldn't print this. So let's do a, let me see this. Let's do a cache here, right? If word not in F, return F word. Otherwise, F word equal to mask. Finally, return F word. Right. So that way, we can compute. We compute stuff. Oh, wow! Ah, look at that. Submit. Maybe all we gotta do is just cache stuff. Okay. Lesson learned. Maybe caching stuff. That means we should study cache next, right? Okay. Also, if we do, instead of will we be passing? Let's do another approach here. If we do, oh yeah, what do I do? Call this solution 1 is whatever this is. Copy our stuff here. Not bad. N square, of course. Maybe this is the solution for. No, it's not ON square. Let's think about that next. But I just wanna know. You can sell dot solution one. Hey, I just wanna know if instead of right here, if we do the same but we also cache, does it pass? Right, this solution that we have right here, I think it goes too. And the bit math just improve the stuff a little bit. 763, okay, 763, remember that. It'll be 763 milliseconds. Oh, what is it? Step solution 2. Right, so we could also do the same idea here. For this, right? So frequency here, FC. If word in FC, return FC of word, otherwise return it. Also return FC word, and here FC word equal F, right? So then if we do solution 2, will the runtime be crazy? Actually, this is just 1 O for one original, which is add cache. Yeah, it passed too. Right, no big deal. Yeah, the original solution works as well. We just need to add cache. Let me submit this and see. 4439. This is like, it's worse, right? 899. What? How does this runtime better? It make no sense to me. What is actually perform better than the bitmask solution? Low, right? Okay, make no sense, but we will try later tonight and see if we can, like, at least we happy that we able to complete a solution. It's like, but let me think. Hold on. Think for like 10 minutes to see if we can have a better solution, right? Because our solution kind of worked, the benchmark is okay. See, the runtime crazy. It's actually better, but the memory is not better, right? Like, but I'm okay with this, and I'm gonna see if we can find another solution that is better than this. So this is ON square. Is it possible to do ON or ON log n at least, right? So somehow, is this possible to find an O up N or O up, sorry, O N or O N square, which, oh no, N log N. So for a heavy word, we need to find that they are, quickly find that the a different character is the same, right? So basically, if we can group them into group that is the same in this way, A, B, C, W, B, A, Z, B, A, R, B, A, Z, B, A, R, right? And then we have A, B, C, D, E, F, right? O, X, D, F, N, right? And also F is here, A, B, C, D, E, F, right? Right, we have these. So out of these, the common we need to do, we want to nail down to just A, B, C, W, right? So intersection between these, we need to minus intersection, right? And then we become full XDFN, right? So after this, we still gotta do the ONs. We still have to loop through to see which one is bigger, right? But maybe we can sort this, right? So this will be ABCW, BAZ, BR, right? XDFN. Then we'll just have ABCW and XDFN. Right? Is that what it is? Try with a different example. So we have A, AB, ABC, D, CD, BCD, right? BCD exists in both. Right, ABCD, ABCD. After we get rid of the common between them, yeah, it will become A, AB, ABC, right? Will become DCD, DCD. Oh, BCD exists in both, right? So sorry. BCD and ABCD exist in both. So does it make it ABC multiplied by CD? Right? Wait, what happened with ABC? Oh, because this have common, right? So basically we do okay, we do a for loop of comparing the max, eh? but because they are common, got them. I don't know. I'll think about this more later on, but then let's go look at the discussion. See what people do. Oh, let's just ask lead Gemini, right? See if we can learn from that. What are the approaches for this? This mask. Oof. This is what I did. Oh, so they do. If the input contain many words with the same set of characters, storing the maximum length is math. What? I don't want to look at the solution. Yeah, this is my solution. Right. Is there a better solution than O of n squared? Really? Okay. So probably fine with this. Okay. Maybe there is no better than O of n squared. I don't know. Okay. Fine. It's amazing that the solution I have here for array, right, actually like works better than the bis mask. Oh my god. How? But yeah. Let's take a break, look at some of the article, then look at some article, and then we take a break for lunch something, and then we play games, and then at night time we'll be back to this, maybe, hopefully. What article should we look today? I'm looking at the Ready programming. Okay, so read and react component did mount. can I sign in here with Substack? Yeah, it's backed by Substack, it seems like. Buff. Photo buff. Okay. Photo buff engineer. Google moving format, right? Remember that. Google photo buff main. Yeah, this one. Yeah. Different stroke for different folks. %, 96% don't trust the output. You won't agree AI often produce. Okay, that's fair. Always review, guys. North America is by 52%. %42% is AI generated. Okay. Okay, number one use case is documentation. Okay. Fair. I use it too. Okay. Explaining, understanding existing code by coding too as well. Wow. Just screenshot this later on. Hmm. Okay. It requires a lot of effort. Yep. It is your prompt, my man. Oh. GitHub and ChatGPT lead the field, really? Really? Interesting. Okay. Hmm. Let's follow the guy first. Basically trust but verify, guys. Trust but verify. Can I do some emoji? Emoji programming. Okay. Let's do a duck. Duck emoji. Okay, I think that's for half the day. Let me eat lunch. Then I